California, located in the west of the American continent alongside the Pacific Ocean. It captures imaginations across the world, boasting famous cities such as Los Angeles and San Francisco. Yet the richest and most populous state in the United States is actually a little-known land. A territory in which geological phenomena have created spectacular landscapes, such as the deserts that Californians have managed to conquer over the centuries.
My great-grandfather came to the valley in covered wagon, and the key was water.
It's our gold here in the desert. Without it, there would be no farming. It would be just desert.
The victim of unprecedented droughts and fires, California is also one of the most unstable seismic zones in the world, traversed by the famous San Andreas Fault. The prospect of a devastating earthquake, known as the Big One, striking at any moment looms over the state's inhabitants.
Anything swaying, then you get nervous.
San Francisco was devastated once. It's going to happen again.
But the conquest of this extreme land, which has been overexploited for centuries, has also caused major environmental disasters. Now more than ever, Californians are forced to live side by side with nature.
Producing green energy is a way of life. Will we make a difference? Yes.
One hour east of Los Angeles in the south of California, Palm Springs is a city popular with Hollywood stars. With palm trees, villas and swimming pools as far as the eye can see, it's hard to think of this as an extreme landscape. But the city is actually an artificial oasis built by man in the middle of the desert. It's located in the scorching hot Coachella Valley, where temperatures regularly reach 45 degrees Celsius. A desert basin formed over 20 million years, at the point where the San Andreas Fault, one of the most active on Earth, begins. A huge moving scar cutting through the Earth's crust, San Andreas crosses California from north to south, stretching 1,300 kilometers. Here, the Pacific Plate and the North American Plate slide against each other. As well as burdening the population with the threat of the Big One, the fault line has shaped some of the largest deserts in the south of the state. To better understand how this gigantic fault line works, geologist Jan Klinger is studying San Andreas to the east of Palm Springs. It is responsible for some amazing phenomena in the desert.
So here we are really in the fault zone. It's maybe 100 meters wide, okay? And we have all this water coming from the hills, gets stuck on the fault zone. So the water will get out of the ground and all those palm trees, they will just suck the water. So outside the fault zone, pretty much no vegetation. And here it's like not rainforest, but a lot of vegetation.
Tracking the water is a good way for geologists to detect fractures in the fault. Jan Klinger explores the depths of San Andreas, which has given rise to many large hills and parched canyons. Spectacular traces of the world's most active fault line.
So we have all those cracks, which are nicely used by water now for erosion and making those amazing canyons. This is all due to combination of the tectonic and the erosion here.
Fractures are created by the intense compression of rocks in this chaotic zone between two branches of the fault. Far from being just a single cut in the Earth's crust, San Andreas is actually a system of hundreds of fault lines running throughout California. The network has a span of almost 150 kilometers in the south of the state.
So here we are actually not really on any plate. Okay, we have this direction east. Very quickly we'll get to a real North American plate. Now on that side, we have one strand of the San Andreas and another one, and then a couple of secondary strands. So we are in between, not really anymore on the North America, not yet fully on Pacific plate. We are in between different strands, which makes these messy places like here where we get a hill, or if the geometry is the other way around, we get a sag.
In Southern California, the San Andreas network has created a series of hills and deep desert basins. In the far east of the state, the tectonic plates have even created one of the lowest points on the planet. A desert larger than the state of Delaware that few men have dared challenge. This is where one of the highest ever temperatures on the surface of the Earth was recorded. A legendary and dreaded place known as Death Valley. The record air temperature is 56.7 degrees Celsius. The record ground temperature is 93 degrees Celsius. The longest recorded time without a single drop of rain here is barely believable. 24 years. In the heart of this natural area, Badwater Basin, standing at least 86 meters below sea level, is the lowest point in North America. The extreme topography here is the legacy of the exceptional tectonic forces that shaped California.
The idea is that this area was actually high. The Panamint Mountains over to our left are being pushed to the northwest. And it's all related to the San Andreas Fault. San Andreas Fault has a big bend in it. And as San Andreas keeps moving, it opens up this gap. And it's stretching the crust out. And each mountain range gets pushed down and the valley forms in between it as it gets stretched out.
Millions of years ago, the movement of tectonic plates slowly shifted the mountains that dominated the region by over 3,000 meters, stretching the Earth's crust, making it thinner and thinner. This created fault lines that caused part of the Earth's surface to collapse, gradually forming the deep basin of Death Valley. The extreme topography accounts for the sweltering heat in the valley. The basin is victim to the high mountain ranges that surround it. Moisture from the Pacific Ocean is captured by the mountain peaks, falling as rain and snow. As a result, the air that enters the valley is very dry.
The humidity in general is just low. It's oftentimes 10%, which is extraordinarily low. In our normal day-to-day areas closer to the coast, it's up to 30 or 40% humidity. If it gets down to 10, yeah, it really takes it right out of your skin. You think of yourself as a wet sponge and you're drying out during the day. That's kind of the way it works here. And not only is it hot, but it's also very dry. And so that's the real hazard here.
At the bottom of the burning valley, the extreme aridity has sculpted an otherworldly extraterrestrial landscape. Like these huge plateaus of crystallized salt, the remnants of a lake that once covered the bottom of the valley thousands of years ago. An immense expanse of fresh water that has now totally evaporated. This extreme aridity is also responsible for some amazing scientific phenomena. During an unusual expedition in 2013, Dr. Richard Norris and his cousin James solved the oldest geological mystery in Death Valley, documented by the miners of the region at the beginning of the last century.
A place where rocks move without any obvious reason. A number of people have tried to figure it out, and my cousin Dick and I decided that we'd give it a go ourselves.
This curious phenomenon can be seen after a 5-hour drive through rough terrain at the bottom of Death Valley. On the bed of this dry lake, huge rocks seem to have been pushed across the earth for several hundred meters by a mysterious force.
What we tried to do is determine how hard it was to move a stone. So what we did was we wetted a playa and then dragged stones across it and measured the force to do that. What we found was that dry was pretty hard to move, but if you flooded the playa, so you had a little layer, a couple centimeters deep of water around them, they moved easily. So what we needed was a pool of water.
This is the problem. So
it's a little dry.
Course, yeah, it's a dry lake, and probably here enough rain falls maybe every decade. So clearly not a common process.
To shed some light on the mystery, engineer James Norris decided to track the movement of the stones by inserting a GPS system into 15 of them, recording their exact position and speed of movement.
We had to revisit them about once every 4 or 6 weeks to keep taking care of the battery, maintaining batteries and things like that. So, yeah, we had to visit a lot to keep this system running.
For 2 years, of course, before anything happened.
By comparing the results with meteorological data, the two scientists discovered that something was happening during the winter. In December 2013, they visited the site at a time when the desert was unusually covered with a 7-centimeter layer of ice.
As we watched this big pond with this floating ice on top of it slowly melt, it started to go pop, 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 all over the surface. And I said to Jim, Jim, this is it. It's going to happen now. And it did.
It's a rock sitting in a pool of water with a sheet of ice afloat like an iceberg, driven by the wind that bumps into this rock and forces it to move.
The Arctic in the desert.
Water and ice in the hottest, driest place on the planet. Yeah. It just doesn't really make sense. Yeah.
In Death Valley, as in all the great Californian deserts, water is a rare resource. South of Palm Springs, movement of the San Andreas Fault triggered the collapse of the Earth's crust to form another desert basin. Coachella Valley, where only a few dozen millimeters of rain fall every year. It's very difficult for man to survive in a desert like this, or even to grow anything. And yet, More than a century ago, the pioneers who conquered the West moved into these hostile lands, slowly transforming the desert into a gigantic arable oasis.
So this was a very arid desert with just salt flats, with very little vegetation, and some areas no vegetation at all. And the key was water. And they arrived in covered wagons following the discovery of the artesian aquifer, that once wells were drilled, that water could then be brought to the surface naturally under pressure with no pumping required.
Thanks to the underwater springs discovered in the valley since 1905, farmers here have managed to produce a wide variety of crops that flourish in the water and under the sun. In particular, date palms, a species usually found only in the natural oases of the desert. But soon the water table ran out, compromising agriculture in this desert area.
So that led to plans to then bring in water from the Colorado River. So this was the time when the Hoover Dam was being built on the Colorado River system, creating the largest reservoir of water in the entire United States.
For almost 20 years, pioneers embarked on a gigantic undertaking, digging the largest aqueduct in the world through the desert, the 196-kilometer-long Coachella Canal. To bring water all this way, they had the brilliant idea of using the unique topography of the valley, located 69 meters below sea level.
The river, as you can see, is not a straight line, and it follows the contours of the ground surface so that we maintain a decline of about 1 inch per mile, so that by gravity, no pumping required, the water will flow from the river to its terminal point. And that abundant water supply then provided what settlers needed to turn this desert into one of the most productive farming areas of the United States.
To transform their extreme land into a rich agricultural resource, the Coachella farmers faced another problem inherent to deserts: salt in the soil. Because normal levels are far too high to allow anything to grow, the land must be regularly flooded to flush out surplus salt through an underground drainage system. It's an operation that winemaker Anthony Bianco is forced to repeat constantly.
In the Coachella Valley, because this used to be ocean, there's a lot of salt here in the soil. But bringing the water to this soil flushes that salt away. But it's a constant battle. If you didn't run your water for a long period of time, your salts might come up. So it's a constant pressure of water in a certain area that helps flush those salts away.
To save Colorado's water, since the 1970s, most farmers in the valley have turned to drip irrigation technology,
which has enabled us to reduce our water consumption by 50%. We don't need water out here in the middle because the roots are not growing out here in the middle. The roots are right here. We're trying to just hit that area precisely. This way we don't waste any water. It's our gold here in the desert. Without it, there would be no farming. It would be just desert.
While saving water is a priority for desert dwellers, with intensive soil irrigation, the flow of the Colorado River has been considerably reduced in recent decades. The large dam lakes that feed the canal are now at half their capacity. Overexploitation of these natural resources has triggered another ecological disaster. Just south of the valley, the lowest point of the Coachella Desert was flooded over an area of more than 1,000 square kilometers following a burst dam on the Colorado River in the early 20th century, creating the Salton Sea, a huge lake and the largest in the United States. The problem is, it is fed by water draining off agricultural land, loaded with salt and pesticides. The intense heat leads to constant evaporation, concentrating the salt and pollution. It's a deadly cocktail for the fish in this artificial sea.
Yeah, it's a shame. It looks like sand, but it's not. This is all different bone. See, these are all fish bones.
And nobody's really using the sea anymore.
Not at all because of that.
The intense evaporation creates a chemical dust, which is swept into the atmosphere by the desert winds, increasing respiratory diseases in local inhabitants and driving them away from the area. In recent years, this former seaside resort has become but a distant memory. It bears witness to a time when Californians thought they had conquered the desert. Today, California has no choice but to live peacefully alongside nature. Californians decided to exploit their desert climate, setting up wind farms across this large arid area, as well as huge solar power plants. Some of them are the most powerful in the world, producing 11% of California's total electricity needs. Around the state, a series of initiatives have sprung up to harness the state's exceptional energy potential, with more than 300 days of sunlight a year. To overcome the lack of space in the more built-up urban areas, a French innovation has been spreading rapidly in California: floating solar power plants. Installed on unused stretches of water, like this one on a farm's irrigation basin, this creative solution helps its owner to achieve energy independence while optimizing electricity production. Surprisingly, the photovoltaic cells that make up the solar panels are sensitive to the heat.
Over like 25 degrees Celsius, you're losing 0.5% of the efficiency of the panel.
I'll give you an example. If these were on the roof, when the sun hits the roof, it heats up the roof. And since the solar panels are close to the roof, the ambient temperature is affected, and so the voltage drops on the solar panels. Being on the water, the sun doesn't heat up the surface of the water and therefore the ambient temperature so much. So the solar panels are actually a little bit cooler, and they produce 5 to 15% more being on the water during a hot day than on a roof during a hot day.
That's quite a lot when you're working in solar, yeah. We have another advantage, which is to limit the evaporation. I mean, here in California, the summertime is really, really dry. It's really hot. And that surface of water covered with our float with the panel is going to reduce the evaporation, and we can save water.
California is known for being bold when it comes to environmental protection, as demonstrated by a ruling that from 2020, any new residential accommodation must be constructed with solar panels.
So there's a big push for solar in California, not only from legislators, but from the people. That isn't to say Americans don't like their big cars. We do. That's just part of our culture here. So America in general, I guess, using energy as a way of life. In California specifically, producing green energy is a way of life. Yeah. California is currently 11% powered by solar. So, you know, Jerry Brown's initiative for going by, carbon neutral by 2045. That includes all renewable energy and nuclear, which isn't necessarily renewable. But just the goal of shooting for the stars, you know, even if we come short of that, we've still done something amazing by going forward and coming close. So will it happen? I can't say. I doubt it, but will we get close? Yes. Will we make a difference? Yes.
For Californians, the reduction of CO2 emissions has become a matter of urgency, especially since over the last 100 years, Southern California has warmed by 3 degrees and now has to deal with historic droughts. As a result, in recent years, the extreme aridity of the Earth has triggered huge fires across the territory. During the increasingly frequent forest fires over the last 5 years, no fewer than 102 million trees have perished from the north to the south of the state. For Californians, growing urbanization has increased the threat. Today, 1/6 of the state's residential properties are in risk areas. With nearly 40 million people, California is the most populous state in the US, with large urban areas like San Francisco and Los Angeles. In addition to the extreme weather conditions, the population lives under the constant threat of a devastating earthquake set off by the San Andreas Fault. According to some predictions, an earthquake of a magnitude of 7.8 on the Richter scale could be triggered at any time in the south of the state. The phenomenon is caused by the Pacific and North American tectonic plates. When they slide against each other, most of the time the rocks stand firm. But after being placed under stress for hundreds of years, they suddenly reach their breaking point and release accumulated energy. Then an earthquake occurs. Although it sounds like a scripted plot for a Hollywood disaster movie, this scientific hypothesis is anticipated on many blocked sections of the San Andreas Fault, which crosses the state along a stretch of no less than 1,300 kilometers. Moving up the fault to the north, Parkfield is literally located across both the Pacific Plate and the North American Plate. This small village has proclaimed itself the world capital of earthquakes because it feels, on average, an earthquake of a magnitude of 6 or more every 22 years. Seismologists pay particularly close attention to the region. People like Dr. Peggy Helweg, a researcher at the University of Berkeley. The scientist controls the operations of a seismological station. Thanks to an ultra-sensitive seismometer located underground at a depth of more than 200 meters, the system is able to monitor the slightest rumbling in the earth, detecting signals coming from as far as 40 kilometers below the surface, and even further when seismic activity is calm.
What we see at a seismic site are ocean microseisms. The wave interaction with the floor of the sea produces these signals. Under quiet conditions, the main thing we see is the ocean microseisms. This station is there to measure big earthquakes, but also to measure the tiny little whispering of the fault that we call tremors. Tremors are a tiny signal that happen on faults. Maybe on all faults, we don't know, but we found them in particular on faults here in the San Andreas. And there is a suggestion that tremors happen just before the big earthquake. But we hope that from these tiny whisperings of the fault, we can learn more about how faults work and why big earthquakes happen.
Despite this discovery, it is impossible today for scientists to predict an earthquake.
As far as we know, these instruments cannot predict earthquakes. They can't say, oh, tomorrow there'll be an earthquake, or in 15 seconds there'll be an earthquake. But if an earthquake starts, they can measure them quickly, and we can use that information to say, a big earthquake has just started. Please take your preparedness actions.
This early warning system relies on two types of wave created by earthquakes. As soon as they are detected by the deep underground station, data about the first types of wave, fast-moving P waves, are instantly transmitted 300 kilometers north to the Berkeley Control Center. There, a computer program deduces that secondary waves, known as S waves, are forming on the surface. The alert is then launched.
Earthquake, earthquake, moderate shaking expected in 14 seconds. Earthquake, earthquake, moderate
So the yellow line is the P wave, and you can see it's traveling faster. And the red line, which is lagging farther and farther behind, is the S wave, which is the wave that will bring us strong shaking. In about 2 seconds, we would feel the shaking. We had more than 20 seconds of time between the P wave and the S wave.
It may not seem like much time, but it could save lives in the event of the big one striking.
In 5 seconds, you can certainly get under the table and hold on. Other actions must of necessity be automated actions. We can stop the elevators at the floor and let the people get off the elevators. If the alert goes to, for example, the BART train system in the Bay Area, they automatically feed them to the train so that the trains stop. The people, power system, the hospitals, the bridges, they can make these decisions about what would be useful in terms of reducing damage and improving their resilience, their ability to recover in an earthquake.
To protect the population, a range of smartphone apps are being developed to raise the alarm. Such innovations are essential tools to protect the USA's most populous state, with 40 million inhabitants, 7 million of whom live in San Francisco Bay. Yet this densely populated area is not only threatened by the San Andreas Fault. Many towns in the region lie in another fault zone, called Hayward. In Fremont, the subtle slipping of the fault causes a lot of damage.
See over here, and then you go all the way. So it's basically dissecting Fremont in half.
Geologist Joyce Blueford is responsible for raising awareness of this seismic risk to the city by showing the public cracks caused by the Hayward Fault Zone.
This is what I wanted to show you.
Oh, wow.
The fault goes where the fault wants to go. 1972, a janitor came here and just seen a crack. Didn't know what it was. Then we realized that it was moving, and so the tiles slowly but surely went from here and started moving, and they started moving all in the same direction, and that's the evidence for creep. You can actually see offset.
Thanks to the measures instigated by scientists and local authorities, Californians are now bracing themselves for the big one.
It is on your mind.
You attach the bookcase to the wall.
Yes, I have
So that it does-
because they're going to fall over and keep you from getting out or falling on you.
I have an earthquake kit in my car. It's water and first aid and a good pair of walking shoes.
Things so you can survive yourself maybe for 3 days. Anything hanging, then you get nervous. It's part of the price you pay to live on the coast of California.
In addition to the threat of the big one, Californians have to live with the damage caused by the inescapable movement of the Pacific and North American plates in San Francisco Bay. Evidence of which can be seen on the campus of the prestigious University of Berkeley. The Memorial Stadium football field is located right on top of the Hayward Fault. It runs beneath the playing area and, more importantly, the sections housing 73,000 spectators. Deformation caused by the almost imperceptible slip of 4 millimeters per year is closely monitored by university researcher Roland Bergman and his team.
So this is what we use to measure positions really precisely. And if we keep doing that, we can see the Earth move. And so here along the Hayward Fault, we're obviously interested in seeing how the fault moves every year. And with GPS, if we process the data appropriately, we can get our measurements to be as accurate as just a couple of millimeters. So very quickly, is it possible for us to see small-scale fault movements that we're interested in.
Because of the movement of the plates, the stadium, weakened by many structural cracks, was recently rebuilt using an ingenious earthquake-resistant system. It has been constructed in 2 parts. In some places, metal plates cover hollow spaces, allowing the structure to move more easily by perfectly aligning to the movement of the tectonic plates.
It's really 2 separate structures now. So part of the stadium that's on the North American side and the part of the stadium that is on the Pacific plate move completely independently. 2 strong structures moving side by side.
The earthquake-resistant structure is essential in the battle to limit damage during the next big one, due to occur very soon on the Hayward Fault.
It's overdue. And on average, we know from geological studies that on average, the Hayward Fault has an earthquake roughly every 150 years. Okay. So the Hayward Fault is ready today. And that would be a big one.
Californian scientists know all too well that the question is no longer if the big one will strike, but when. According to them, there is a 70% chance that a major earthquake will occur in San Francisco Bay sometime in the next 30 years. One of the world's most legendary cities, San Francisco risks being severely affected by the shockwave. An unstoppable wave could hit the iconic Golden Gate Bridge. Not to mention the city's winding streets, swarming with almost 1 million inhabitants. It's hard to believe that the anger of the Earth could manifest itself here. Yet San Francisco has already been devastated twice before. The first time in 1906. And again more recently in 1989, when a big one registering 7.1 on the Richter scale left 63 dead and 3,700 wounded. In addition to the thousands of collapsed buildings, the earthquake also destroyed a section of Bay Bridge, the busiest in the city, totally paralyzing the area. To prevent this chaos from happening again, California's engineers have developed imaginative new ideas. In 2013, they completed a brand new earthquake-resistant structure, one of the most advanced in the world. A suspension bridge with a pylon rising to more than 165 meters in height, as tall as a 40-story building. Its tower is the centerpiece of a new stretch of road connecting Oakland to neighboring San Francisco.
It's actually a self-anchored suspension bridge, which is a very old kind of suspension bridge. But what's really unique about it is, if you notice on the west end, where the cable goes down and wraps around, it doesn't have an anchorage on that side. The only anchorage exists on the east side, so it's very, very unique.
Passing beneath the bridge, the huge cable supporting the road increases the strength of the entire structure. In the center of the structure, the flexible tower is equipped with enormous dampers designed to absorb the shock during the next major quake.
There's going to be another earthquake. San Francisco was devastated once. It's going to happen again. San Francisco needs this bridge to be operational for them to recover.
For the bridge to survive the next big one, Californian engineers also had to find a design that allows it to stretch more than 1 meter. Engineer Bill Casey knows the inner workings of this steel monster like the back of his hand. The heart of the bridge's deck boasts a unique technology that is the pride of Bay Bridge engineers.
We'll look in the hinge pipe beams that allow for the expansion traction from thermal movements. You know, things heat up and cool off, and they shrink and expand between the two bridges, as well as deal with earthquakes, allow several feet of movement between the two bridges. All the energy that's going across between the two bridges gets absorbed here. This damages, this absorbs the energy, dissipates it, and we can replace that after the earthquake.
Easily replaced after an earthquake, this solution will also avoid crippling the bay through forced closure of the bridge to traffic.
Bridges like this are lifeline structures to get help into San Francisco when the big one does hit. You know, they'll have fire, they'll buckle roads, people trying to get home. If there was an earthquake, I'd like to be in this box. The deck will sway back and forth, and the deck will rock and roll, and it'll just, almost like a swing. It'll ride right out an earthquake. It looks very rigid, but it is also very flexible. These structures can bend a lot and sway a lot and absorb a lot of deflection, a lot of energy. If you're here when the big one hits, you'll be in a great place to be.
Bill Casey is eager to share one last well-kept secret about this unique structure. A secret warranting further investigation that is located at a height of 165 meters. The view from the bridge's main tower overlooks the entire San Francisco Bay.
Oh, it's beautiful. San Francisco, Treasure Island right below us.
As it recovered from the devastating earthquake in 1989, the city erected one of the safest, most earthquake-proof constructions in the world.
I mean, you couldn't have built this today if people weren't out of the comfort zone and that really just strive for a higher level. And that's kind of like California, it's that way. You get comfortable, what's the next step? What's the next step? What's the next step? And people do get pushed out, and when you get pushed, you get pretty creative on how to solve stuff. And this bridge right here is a great example of it.
Inspired by its shaking earth, Californians have created an incredible earthquake-resistant bridge equipped to withstand the next big one. But over the centuries, the conquest of this extreme land has come at the expense of California's natural resources. Overexploitation of the landscape has led to some major environmental disasters. Faced now more than ever with the fury of the land beneath their feet, Californians are trying to live peacefully alongside nature and are prioritizing the fight against climate change.